The theorem of Pythagoras is one of the oldest results in all of mathematics. In any right triangle, the sum of the squares of the legs is equal to the square of the hypotenuse. In other words, the sum of the areas of the two small blue squares is equal to the area of the large one. To see why, make 4 copies of the right triangle. Put this here for reference. Now slide the triangles around and just keep track of the areas of the blue regions. And we see that a squared plus b squared is always equal to c squared. Here's another proof. The area of this green region doesn't change if we shear, rotate, and shear again. The same is true for this blue region. And again we see that a squared plus b squared is indeed equal to c squared. Still not convinced? Cut a copy of the small square in the middle of the large square. Make cuts out to the edges. And rearrange the pieces. Here's yet another proof. Divide the triangle into 2 similar right triangles. The area of the big one is the sum of the areas of the 2 smaller ones. Because the areas of similar figures are proportional to the squares of the length of the edges, we get the Pythagorean theorem. Once again, instead of squares or triangles, you can put any 3 similar shapes on the sides of a right triangle. The sum of the areas of the 2 smaller shapes is equal to the area of the large one. To extend the theorem to 3 dimensions, we use the 2-dimensional theorem twice. There's one right triangle on the floor and another perpendicular to the floor. The square of the diagonal of a rectangular box is the sum of the squares of the 3 perpendicular edges.